Okay, so now we have to learn some of the basic points or some general points related with a graph. Okay, these points will be applicable for drawing graph of any function. Okay, so the first point that you need to know is if the equation of a curve does not change when x is replaced by minus x. Okay, then the graph of that function will be always symmetric about y-axis. So let us take some basic examples. Suppose if you see the graph of this function y equals to x square, then we all know that here if you replace x by minus x, okay, in place of x write minus x, so you will get y equals to minus x square, and this is same as y equals to x square. So if you replace here x by minus x, then you are getting the same equation, and this means the graph of this function will be symmetric about y-axis. So these are our coordinate axis, and we all know that this is your graph of y equals to x square, and this graph is symmetric about y-axis. Okay, if y-axis is mirror, then image of this half of the graph on the positive side of this x-axis, image of this portion of the graph will be the other half of the graph. Okay, so here since we are getting the same equation by replacing x by minus x, therefore the graph must be symmetric about this y-axis. We can take some other example. Suppose if you see the graph of y equals to cos x. Now if you replace x by minus x, you will get cos of minus x, which is nothing but cos x. So again if we replace x by minus x, we are getting the same equation, and this means the graph of this function will be symmetric about y-axis, and we all know that this is our graph of y equals to cos x, and this graph is symmetric about y-axis, right? If this was the mirror, then if we take the image of this portion of the graph, then we'll get this graph on the negative side. So this was the first point. In any curve, if you replace x by minus x and there is no change in the equation of curve, then the graph of that curve must always be symmetric about y-axis. So this is first point. The second point is if equation of curve does not change when y is replaced by minus y. Okay, in place of y write minus y, and if you are getting same equation, then it means the graph will be symmetric about x-axis. Okay, again if you want to write some examples here, then the examples that you can think of is, say this graph of y equals to y square equals to x. Okay, in this function if you replace y by minus y, then you are going to get the same equation. Okay, only one example will be sufficient here. So if you replace y by minus y, okay, in place of y, if I write minus y, then I will get minus y square equals to x, which is nothing but y square equals to x. So if you replace y by minus y, then you are getting the same equation, and this means this graph has to be symmetric about x-axis. Okay, and we all know that this is nothing but graph of our right-handed parabola. This will be your graph of function y square equals to x. Now if you see carefully, this graph is symmetric about this x-axis, right? If we take the image of the portion of the graph which is above x-axis, then we'll get the portion of graph which is below x-axis. Okay, so these were first 2 points related with graph of any function. Now we are going to take 2 more points related with graph of different type of functions. Okay, so our next point is if equation of a curve does not change when x and y are interchanged. Interchange means in place of x we are writing y, and in place of y we are writing x. So if you interchange x and y and equation of curve is same, then the graph is symmetric about the line y equals to x. So let me give you one example. Suppose if we have the graph of this function y equals to 1 by x, okay, and here if we interchange x and y, in place of x write y and in place of y write x, then I will get x equals to 1 by y. Now if you see carefully, if you take reciprocal on both sides, then these 2 equations are same. This first and second equation both are same equation. So even after interchanging x and y, you are getting the same equation. So this means the graph of this function y equals to 1 by x is symmetric about this graph will be symmetric about this line y equals to x. Okay, and again if you see the graph of this function y equals to 1 by x, this is nothing but rectangular hyperbola, right? You will have one branch in the first quadrant, another branch in the third quadrant. So this is your graph, these two branches combined is the graph of this function y equals to 1 by x, right? Now if you see carefully, this graph is symmetric about this line y equals to x. Okay, if you take image of any point on this graph in this line y equals to x, then image must lie on the graph itself. Okay, and this thing is obvious because if alpha beta is lying on this curve, then beta alpha also has to lie on this curve only. Okay, suppose if there is, say, x, if I place x equals to 2 here, then what is the value that I am going to get? 1 by 2. So if this point 2 comma 1 by 2 is on the graph, then its image 1 by 2 comma 2 is also on the graph. If x is 1 by 2, then what is the value of y? 2. Okay, so this is again a very important concept. If you interchange x and y and you are getting the same equation, then graph must be symmetric about this line y equals to x. And the fourth point is related with bounded and unbounded function. So this bounded function simply means that the range of y is finite. Okay, if fx is always between two finite number a and b, then this means fx is bounded. And if the limit for x, if the range of fx is infinite, then it is in unbounded function. Let me give you some of the examples of bounded functions. Suppose if you see this function sin x, so what is the range of y here? The range is -1 to 1. If you see the graph of sin x, then this is the graph of function y equals to sin x, and you can always confine this graph between these two lines -1 and +1. No portion of the graph will be below this line y equals to -1 or above this line y equals to +1. So this means this sin x is an example of bounded function. Similarly, cos x is also bounded function because cos is also from -1 to +1. But if you take another example, say y equals to e to the power x. So here if you see the graph of e to the power x, this will be your graph of y equals to e to the power x, right? Because now this will, when x is minus infinity, y will be 0, so it will start from here. As you increase x, value of y will increase, and when x is approaching to infinity, y is also approaching to infinity. So here if I ask you what is the range of this e to the power x, so e to the power x is always from 0 to infinity, right? So maximum value of e to the power x is approaching infinity, and therefore it is not a bounded function. You cannot find two horizontal lines between those lines. This graph will always lie. Okay, the graph is not confined between, you cannot confine this graph between any two parallel horizontal lines, and therefore it is bounded. Okay, you cannot draw any line and you can say that below the line the graph will be always there. So that means this function is not bounded. In simple terms, bounded means range of y is finite, unbounded means you are getting either plus infinity or minus infinity or both the infinity. So this was these were some of the general points related with graph. We had seen our first 3 points were if you replace x by minus x, no change means symmetric about y axis. If you replace y by minus y, then no change means symmetric about x axis. If you interchange x and y, that was our third point. If you interchange x and y, no change in the equation of curve, then it means the curve will be symmetric about y equals to x line. And our last point is related with bounded and unbounded function. Now we'll see two problems based on these concepts. Okay, so now we have these two problems. The first problem was asked in GATE 97, another one in 2007. So the first problem is the curve given by this equation, x square plus y square equals to 3axy. Okay, this is the equation of given curve, x square plus y square equals to 3axy is, four options are given: symmetric about line y equals to x, symmetric about y axis, symmetrical about x axis, and tangential at point a by 3, meaning that suppose if this is some graph, then the curve given by this equation is tangential. This fourth point has no meaning. I mean, this fourth point is obviously meaningless because tangential to which line? No, any line is not given here. So basically we have to see which one of these three options is correct. So here if you see, we have learned we have seen the condition for symmetricity about x-axis, y-axis and the line y equals to x. So in this particular example you can easily see that if you interchange x and y, okay, this is your given equation. If you interchange x and y, then you will get y in place of x, x in place of y, y in place of x and x in place of y. Now this equation can be rewritten as x square plus y square equals to 3axy. Now you can see that these two equations are identical, exactly same equation. So meaning that even if we interchange x and y, we are getting the same equation, which implies that the given function is symmetrical about, this function is symmetrical about y equals to x line. Okay, this was our third general point, that if you interchange x and y and you get the same equation, then the graph will be symmetrical about y equals to x line. So here the correct answer is this option A. Okay, so this was very easy problem. Then the second one is, this is related with bounded and unbounded function. So the second point says, the second question says which of the following function is strictly bounded, and these four options are given. Now in each one of these four options, if you know the graph of these functions, okay, or if you can see the range of these three functions, then you can easily see whether it is bounded or unbounded. Okay, for the first one, y equals to 1 by x square. So the graph of this function is y is 1 by x square. Whatever be the value of x, y is always positive, graph will be in first and second quadrant. When x is very close to 0, y will be infinity, and as you increase x, the value of y will decrease. And here if you replace x by minus x, you will get the same equation. So it will be symmetrical about y axis. So this is your graph of function y equals to 1 by x square. Okay. So here you can easily see that what is the range of y? The minimum value of y is 0. Obviously you will not get exactly 0. You will get 0 when x is infinity. So therefore I am writing open bracket here. So y belongs to 0 to, and when x is very close to 0, the value of y you can see is approaching to infinity. So range of y is from 0 to infinity. Since we are getting infinity in the range, since the range is not finite, therefore this option A is incorrect. Okay, this function 1 by x square is not bounded. This is unbounded function. Option B is y equals to e to the power x. Now if you see the graph of this function e to the power x, we have discussed earlier, this was our graph of y equals to e to the power x. Again you can see that here the range for y will be from 0 to infinity. So since you are getting infinity in the range, this is also incorrect. Okay. Similarly your third option will be, your option C is y equals to x square. Now this we all know is an upward parabola, something like this. So here the range for y will be 0 to infinity. Since we are getting infinity, this is also incorrect. Now notice one small difference in these three. In first two I have written open interval at 0, whereas in third one I have written closed interval. So this will not make any difference on whether it is bounded or unbounded, but you should know the meaning of these things. Open interval means 0 is not in the range. Okay, you will get number greater than 0, whereas here third bracket means closed interval, so here 0 is included. You will get y equals to 0 when x is 0, whereas in these two graphs you will not get 0, you will get a number slightly greater than 0. So therefore I am writing open interval. Okay, so all the first three options are incorrect, first three are unbounded function, and therefore this D has to be the correct option. Okay, now this question we had to solve this problem based on this elimination technique only. First three are standard function whose graph we already knew. So from first three we can see that these three are unbounded, therefore fourth one has to be bounded. And if you want to draw the graph of this function y equals to e to the power minus x square, then the graph is in probability normal distribution. You had seen that we were getting this type of term, right? If you can recall, this was your formula for probability density function. So if you place nu equals to 0, sigma 1, here you had some constant. So this is similar to e to the power x square, right, with minus sign. So there the graph was a bell shaped curve like this. So here also you will get a similar, this will be your graph of y equals to e to the power minus x square. Okay. So and this point will be when x is 0, the value of y will be 1. The graph will be symmetric about this y axis, because when x is replaced by minus x, since you have x square, you will get the same equation. So here the range for y will be from 0 to 1, and therefore it is an example of bounded function. Okay. So these were first two problems on the general points that we had discussed. Now we will see graphical transformation, meaning that if we know the graph of one function, then how we can draw the graph of any other function from there. Okay, so next we have to learn about some of the basic graphical transformation. Graphical transformation simply means we know the graph of one function and some constant is added there or subtracted there, or the function is multiplied or divided by some constant, then how to draw the graph of those function. Okay, so our first transformation will be vertical shift. Okay, this will be our first transformation, vertical shift. So the meaning of this vertical shift is that we know the graph of this function y equals to f of x, and from here we have to draw the graph of f of x plus minus a. Okay, then how to draw the graph of these functions? So for example, suppose if I want to draw the graph of say y equals to x square plus 2. So we all know the graph of this function y equals to x square, right? This was our graph of y equals to x square, an upward parabola. Now suppose if we have to draw the graph of y equals to x square plus 2, then what will happen, that all the points on this curve will shift by 2 units towards positive y axis. Okay, on this graph y equals to x square, you have x0, y0. Now if I place x equals to 0 here, then what is the value of y that we are going to get? Y will be 2. So on this graph there will be a point x0, y2. Say here the value of x is 1, y is 1. So on this graph when x is 1, y will be 1 plus 1, 3. So this point will shift by 2 units. Similarly, all the points will shift by 2 units towards positive y axis, and therefore the graph that we are going to get is a graph parallel to this one but shifted by 2 units towards positive y axis. So this will be your graph of y equals to x square plus 2. This is obtained simply by shifting the graph of this curve y equals to x square by 2 units towards positive y axis. Similarly, if we want the graph of the function say y equals to x square minus 2, then you have to shift the graph of this function by 2 units towards this negative y axis. Okay, so this transformation is called vertical shift. Fx plus a means shift towards positive y axis, fx minus a means shift towards negative y axis. I am considering that a is any positive number. So this transformation was vertical shift, which is very easy to understand. The next one is horizontal shift. Okay, so in horizontal shift what happens, that graph of one function is known. Here the transformation will be graph of this function y equals to fx is known, and we need to draw the graph of this function f of x plus minus a. Okay, so if we have to draw the graph of this function fx plus minus a, then there are two possibilities. One, suppose if we have to draw the graph of this function y equals to x minus a, then suppose we can take some examples here. Suppose we know the graph of this function y equals to sine x. Okay, this was our graph of y equals to sine x. These were our coordinate axis. This was our graph of y equals to sine x, right? Now suppose if we want to draw the graph of this function y equals to sine x minus pi by 4, right? So now what will happen? See, when x is 0, sin x is 0. But for this graph, when x minus pi by 4 is 0, then sin x will be 0. Meaning that when x is pi by 4, okay, this point will be pi by 2. So here you will get pi by 4. So when x is pi by 4, then sin x minus pi by 4 will be 0. Similarly, so what is happening? This point is shifted to here, and similarly all the other points will also shift by pi by 4 unit towards this right side. So now the graph of this function will be, okay, you will get a graph something like this. It will be parallel to this graph. Okay, let me draw this graph. You will get a graph something like this. Okay, all the point on this graph, this is your new graph of this function y equals to sine x minus pi by 4. Okay, if you have x minus a, then you have to shift by a unit towards this right side, and similarly if you have x plus a, then you have to shift by a unit towards this left side. Maybe you can write this f of x plus a, this implies shift towards left side by a. And if you want to draw the graph of this function fx minus a, then it means shift towards right by a unit. Okay, if you want, we can take some other examples also. Suppose if we know the graph of this function y equals to ln x, right? This was our graph of y equals to ln x. Now suppose if we want to draw the graph of this function y equals to ln x minus 2. Okay, so this point was x1 y0. Now for ln x minus 2, when x minus 2 is 1, then y will be 0. So this means when x is 3, then you will get y equals to 0. So for this graph you will get this point x3 y0. So you will get another graph parallel to this one. Okay, so this will be your graph of y equals to ln x minus 2. So if x is replaced by x minus a, then we have to shift this graph by a unit towards right side. And if we had to draw the graph of ln x plus 2, then shift by 2 unit towards this left side. Okay, so this is very important and sometimes it is confusing. So remember, if you have x minus a, then shift towards positive x axis, and x plus a, then shift towards negative x axis. So this was about horizontal shift. Now we have to see some other transformations. Okay, so now last two transformation that we need to learn is, till now we have discussed vertical shift and horizontal shift. Now we have to learn about these two transformation. One is y equals to mod of f of x, another is y equals to f of mod x. Okay, so let me explain these ideas with the help of some examples. Suppose if we have the graph of, if we have to draw the graph of this function, say y equals to mod sin x. So the first step here will be draw the graph of this function y equals to sin x. Okay, so this will be your graph of y equals to sin x. This is your graph of the function y equals to sin x. Now if you want to draw the graph of this function y equals to mod sin x, then for mod sin x what will happen, that all these points, say for sin x this point is giving us minus 1. Now if you take mod of minus 1, you will get plus 1. Here suppose if y is minus 1 by 2, then mod of minus 1 by 2 will be plus 1 by 2. So what is happening, that this, for this function mod sin x, you have to take image of all these points in x axis. Okay, so first step, you have to erase this portion of graph which is below the x axis and then take its image in x axis. Similarly here also erase this portion of the graph and then take its image in x axis. So this will be your graph of y equals to mod sin x. Okay, remember that no portion of the graph should be below this x axis, because y is always positive. Why y is always positive? Because mod of any function, y is mod sin x. Now whether sin x is positive or negative, mod sin x will be always positive. So in order to draw the graph of these type of function, first step will be erase the portion of graph below x axis and then take its image in x axis. You can consider another example. Suppose if I have to draw the graph of y equals to mod ln x. So first draw the graph of this function y equals to ln x. This will be your graph of the function y equals to ln x. Then erase the portion of graph which is below this x-axis. Take its image in x-axis. So this will be your graph of the function y equals to mod ln x. This is the graph of the function y equals to mod ln x. So this transformation is the transformation of y equals to mod of f of x. Another example that you can think of is, this was our first example, second one, the third one, very standard one that you already know, graph of this function mod x. Now by applying the concept that we have learned just now, what should be our first step? Draw this line y equals to x. Then erase the portion of graph which is below x-axis, take its image in x-axis. So this will give us the graph of y equals to mod x, and this we already knew, right? This is our graph of y equals to mod x, a V-shaped curve starting from this origin. So in this way you can draw, you can do this transformation. Now the fourth one is, this is also very important. If we have to do this transformation y equals to f of mod x, so how to do this transformation? So again we will see this with the help of example. Suppose if we have y equals to mod sin x, okay, so this sin x is defined as, mod x is defined as, mod x is x if x is positive, minus x if x is negative. So a first step here will be draw the graph of this function sin x. So this will be your graph of the function y equals to sin x. Now if I want to draw the graph of this sine of mod x, so we all know that this sine of mod x will be sin x if x is if x is positive, right? This will give us, okay, this will be equal to sin x if x is positive, because if x is positive mod x will be x, and this will be sine of minus x if x is negative. So first we can easily see that graph will be sin x for positive x. So for positive x we don't have any issues. This will be the graph of sin x and sine of mod x. Now comes this negative part. So we have learned one important concept, that if we replace x by minus x and if there is no change, this means the graph is symmetric about y axis, right? This concept we have seen earlier. So here also you can see that if you replace x by minus x, then there will not be any change. Mod of minus x is same as mod x, and this means the graph will be symmetric about y axis. So we already know that for mod sine of mod x, this is the graph, and the graph of this function is symmetric about y axis. So this means erase the portion of graph on the negative side and take image of this portion of the graph in y axis. So now this is your new graph. This is the graph of the function y equals to sine of mod x. Okay, so first step, erase the portion of graph towards this negative side of x axis, and then take the image of portion of the graph which is on positive side of x axis in y axis. So this was our transformation y equals to sine mod x. If you want, we can take one more example. Suppose if I want to draw the graph of this function y equals to e to the power mod x. So first step, draw the graph of this function y equals to e to the power x. Erase the portion of graph on a negative side of x axis. Take the image of this portion of the graph in y axis. So this will be your graph of y equals to e to the power mod x. So these two were very important transformation. Now we will see a few questions which were asked on in GATE previous year papers from these transformations. So now we have this one problem which was asked in GATE 2017 in computer science. So this was a very good problem. The question is the number of roots of this equation e to the power x plus 0.5 x square minus 2 equals to 0. In this interval minus 5 to 5 is, 4 options are given, 0, 1, 2, 3. The question was asked for 2 marks. So in our earlier discussion we have seen how to find number of solution of this equation fx equals to gx. Okay, draw the graph of these two functions y equals to f of x and y equals to g of x, and then see how many point of intersection are there between these two curves. This will give us number of point of intersection. Now here you can see that it is not easy to draw the graph of this function, right? Right hand side is 0, but on left hand side you have this function, and it is not easy to draw the graph of this function. So first step will be, if I want to solve this equation, then solving this equation is similar to solving this equation e to the power x equals to 2 minus 0.5 x square. Okay, the number of solution of these two equations will be same, because these two equations are essentially same, except that we have rearranged some of the terms here. So now if I want to find the number of solution of this equation, then I have to draw this graph e to the power x, and I have to draw the graph of function y equals to 2 minus 0.5 x square, and then we have to see how many point of intersection are there between these two curves. Okay, so first we are going to draw the graph of this function y equals to e to the power x. So this will be the graph of our function y equals to e to the power x, right? This will be the graph of our function y equals to e to the power x. Next we have to draw the graph of this. Now this is very important part. Graph of this function y equals to 2 minus 0.5 x square. Now remember that graph of minus x square will be a downward parabola. So graph of minus 0.5 x square, this will also have similar nature. So it will be a downward parabola. Now if I want to draw the graph of y equals to 2 minus 0.5 x square, so this means I have to add 2 here, which means we have to shift this graph by 2 unit towards positive y axis. Okay, so this means the graph of this now one more important thing, the coordinate of this point is x0 y1, right? So this means, and here this point will be nothing but this is 0 0, shift by 2 units, so this point will become 0 comma 2. So for this parabola the vertex will be at 0, at this point 0 2. So if I draw the graph of this downward parabola, we'll get a graph something like this. So this is your curve y equals to 0 2 minus 0.5 x square. Now as you can see that there are 2 point of intersection between these two curves. Okay, one is e to the power x and other is this y equals to 2 minus 0.5 x square. But this question becomes a very good problem, because it is given that we have to find the solution only in this interval. Okay, if the solution is outside the interval, then we don't have to count that. We have to find only those solutions, those value of x which are lying between minus 5 to plus 5. So how to identify whether these 2 points are between these two extreme limits minus 5 or 5, minus 5 to 5 or not? So for that there is a very important technique. See, for this graph y equals to 2 minus 0.5 x square, if I equate y equals to 0, if I equate y to 0, then I will get 2 minus 1 by 2 x square equals to 0. This will give us x equals to minus 2 and plus 2. Now what are these 2 points? These 2 points are nothing but point of intersection of this downward parabola with x axis, because y equals to 0 is nothing but equation of this line x axis. So this means that the point where this parabola is crossing the x axis are minus 2 comma 0 and 2 comma 0. So x equals to minus 5 will be somewhere here, x equals to plus 5, this will be somewhere here. The question was how many point of intersection are between minus 5 to plus 5. So these 2 point of intersection are between minus 2 to plus 2. So it has to lie between minus 5 to plus 5. So therefore here the number of solution will be 2. There are 2 point of intersection and both of them are in this interval minus 5 to plus 5. So correct answer here will be option C. Okay, so these were some of the basic concepts and questions based on the graph of different type of function. After this we'll talk about limits of a function. Okay, so there was one very good question in GATE 2018 in mechanical department based on the concept of graphical transformation. Okay, so this was the question: which of the following function describes this graph? 4 options were given and you had to identify which one of these functions we'll have a graph similar to this one, or in fact exactly this one. So here we need the concept of graphical transformation. Okay, so we are going to see the graph of each one of these four functions, and then we will see which one is the correct option. So our first function was, option A is y equals to mod x plus 1 mod x plus 1 minus 2. Now let me show you how to draw the graph of this function. So the first step will be draw the graph of this function y equals to mod x. Okay, so these are our coordinate axes. If I want the graph of y equals to mod x, then we have seen in our earlier discussion that this was the graph of the function y equals to mod x, right? Now if I want the graph of this function mod x plus 1, then it means we have to shift this graph by 1 unit towards positive y axis. Okay, graph of this mod x plus 1, this will be, we have to shift this graph by 1 unit towards positive y axis, so we will get this graph. This will be your function y equals to mod x plus 1. This point will be x0, y1, right? This was point 0, 0, so this will move to point 0, 1. Now we have to take the mod of this function. So if you have to take the mod of this function, then we have learned how to take modulus of any function. Erase the portion of graph which is below x-axis. Now you can see that this graph is completely above x-axis. Okay, so this means we don't have to do any change here. This graph is also the graph of function y equals to mod of mod x plus 1. Okay, so now we need to draw the graph of this final function. We have drawn the graph of this function mod of mod x plus 1. Now we need to subtract 2 from here. So this means we have to shift this graph by 2 unit towards negative y axis. This was our positive y axis. We need to shift this red graph by 2 unit towards negative y axis. So now the graph that you are going to get is something like this. This will be your graph of function y equals to mod of mod x plus 1 minus 2. Okay, so and what will be this point? This point will be x0, y1. So as you can see that this graph is nowhere close to the given graph, and therefore this option A is incorrect. Now we are going to see what should be the graph for this option B. So again we have to go by the same basic rule. We need to draw the graph of this function mod of mod x minus 1 minus 1. So first we'll start with the graph of this function y equals to mod x. First we'll start with the graph of this function y equals to mod x. So let me show you this graph. These are our coordinate axes. This will be our coordinate axis. Now this was our graph of y equals to mod x. This is our graph of function y equals to mod x. Now we need to draw the graph of this function mod x minus 1, right? We have mod x minus 1 here. So now we need to draw the graph of this function mod x minus 1. So this means shift the graph by 1 unit towards negative y axis. So now the graph that you are going to get is, this will be a line parallel to this line. So you will get a graph something like this. This is your graph of y equals to mod x minus 1. Now in the next step, we have to take the modulus of this function. Now taking modulus of this function means erasing the portion of graph which is below x-axis and then take its image in x-axis, right? This is how we used to draw the graph of mod of fx. So now if I want to take the mod of this function, then erase the portion of graph below x-axis and then take its image in x-axis. So now you are going to get a graph something like this. And what will be the coordinate of this point? This point was x0, y minus 1, right? Mod x minus 1, so we have shifted this graph of mod x by 1 unit, so this was 0, minus 1. So this point will be x0, y plus 1 because we are taking the image of this point in x-axis. Now the final step, we have to draw the graph of this function mod x minus 1 minus 1. So now this red graph, okay, this red graph was the graph of this function inside the red bracket. Okay, this was our graph of y equals to mod of mod x minus 1. Now we need to subtract 1 from here. So this means we have to shift this red graph by 1 unit towards negative y-axis. So this means the graph that you are going to get is this point will move here, this point will move to origin, this point again by 1 unit. So you will get a graph something like this. Okay. This will be your graph of function y equals to mod x minus 1 mod of this whole function minus 1. And as you can see, this what should be the coordinate of these 2 points? So this point was x minus 1 y 0, right? This point was x plus 1 y 0. We have shifted this graph by 1 unit, and we all know that the slope of this line is minus 1, slope of this line is plus 1. So if there is 1 unit decrease in x, then decrease in, if there is 1 unit decrease in y, then decrease in x is also 1 unit. So this point will be minus 2 comma 0, and here you will get plus 2 comma 0. Okay, and you can verify that these 2 points are lying on this graph. If I place x equals to 2 here, 2 minus 1 1, mod 1 1, 1 minus 1 0. Similarly, you can show that this point is also lying on that curve. So finally, this is your graph of function y equals to mod x minus 1, and you can see that the given graph is exactly the same graph. So therefore our correct answer is option B. Okay. If you want to draw the graph of other functions, then you can draw the graph in a similar manner. If you want to draw the graph of this option, say C, then here you have to first draw the graph of y equals to mod x plus 1 means a shift by 1 unit towards positive y. You can see that this option A, okay, these two, option A and option C, are similar, except here you have minus 2, here minus 1. So if you have minus 2, then we had shifted this graph by 2 unit. For minus 1, we'll shift the graph by 1 unit. So in fact, here the graph that you are going to get is simply the graph of y equals to mod x. Okay, because if you see that, if you see this function carefully, then this is nothing but mod x plus 1 minus 1, right? Because this is always going to be positive, and for a positive number you can directly remove this mod sign. So you will get mod x plus 1 minus 1, these two will cancel. So option C is y equals to mod x. Okay, we know how to draw the graph of this function. We are going to draw one more, we are going to see the graph of this function also. How to draw the graph of this function? We have obtained our answer, the correct answer is option B. But we are going to see what will be the nature of graph of this function. Y equals to mod x minus 1 modulus of this whole function. So now again we are going to start with the basics here. These are our coordinate axes. First we need to draw the graph of this function y equals to mod x. Now next we need to draw the graph of this function y equals to mod of x minus 1. Now as you can see that here x has been replaced by x minus a, where a is 1. So we have seen in our earlier discussion in case of horizontal shift that if I replace, if we want to draw the graph of this function fx plus minus a from the graph of this function y equals to fx, then if you have plus sign, then you need to shift the graph by a unit towards negative x-axis, shift towards left. And if you have minus sign, then you need to shift graph towards right. So here also you need to do the same thing. Mod x minus 1 means you have to shift the graph of this function y equals to mod x by 1 unit towards right side. Okay, minus a means shift towards right. So this point is 0 0, this point will be 1 comma 0. If I shift this graph by 1 unit, this will be our graph of function y equals to mod x minus 1. Now in the next step we have to subtract 1 from this function. So if you have to subtract 1 from this function, then it means you have to move this graph by 1 unit towards negative y-axis. So if you shift this graph, then you will get a graph something like this. Okay, this point will move here. This was 1 1, so here this point will be x1 y minus 1. So you will get a graph something like this. This will be your graph of y equals to mod x minus 1 minus 1. Now in the final step we have to take the modulus of this function. So this means erase the portion of graph which is below x-axis and then take its image in x-axis. So finally you are going to get minus 1 minus 1 will become 1 plus 1, so you will get a line overlapping this line, and then you have to join these 2 points. So finally this red graph is the graph of function y equals to mod of mod x minus 1 minus 1. Okay, so this was all about this question. We have seen that how to solve this using this graphical method by graphical transformation. But there is another method of solving these type of problem, and that second method is based on eliminating the options. Okay, we know that there are 3 points minus 2 0, 0 0 and 2 0 lying on this given graph. So this means now we are going to check that which one of these 4 functions is satisfying the coordinate of all these 3 points. So if we start from option A, then you can see that in option A, if I place x equals to 0 here, then I should get y equals to 0, right? Because 0 0 is lying on this graph. But you can clearly see that if I place x equals to 0, then I will get 0 plus 1 minus 2. So when x is 0, this function is giving us y equals to minus 1. So therefore this option A is incorrect. Okay. In option B, you can see that if I place x equals to 0, then I will get y equals to mod of minus 1 plus 1 minus 1. So this is giving us 0. So we move to the next point. Okay, we are going to check for this origin in each one of these 3 options, then we will take other points. So for 0 0, this option B is okay. Now for option C, if I place x equals to 0, then I will get 1 minus 1, again 0. Here also you will get 1 minus 1 0. So 0 0 is satisfying all these 3 equations. So from this origin you can eliminate only option A. Now when x is 2, the value of y should be 0, right? First we have checked that when x is 0, y should be 0. So option A was eliminated. Now we are going to check when x is 2, y should be 0. So in option A, if I place x equals to 2 here, then I will get 2 minus 1 1, 1 minus 1 0. So this is satisfying this point. Option C, 2 plus 1 3, 3 minus 1 2. So when x is 2, the value of y that we are getting from here is 2, and therefore this option C is incorrect because it is not satisfying the coordinate of this point 2 comma 0. Now comes option D. If I place x equals to 2 here, 2 minus 1 1, 1 minus 1 0. So now B and D both are satisfying this second point. So we have one more point to check. When x is minus 2, the value of y is again 0. So if x is minus 2, you can see from here that the value of y that you are going to get is minus 3, mod of minus 3 plus 3 minus 1, so 2. So again this fourth function is not satisfying this coordinate of this point, and therefore correct answer has to be option B. So in this way also you can solve these type of problem, but you should know how to draw the graph of these type of function using graphical transformation. So now we are in a position to learn limits.